Sounds good, right? Okay. So multiplying with complex numbers. Remember that the standard form of a complex number is a plus bi, where a is the real part and bi is the imaginary part. If I is the imaginary number and it's defined, the imaginary number I is defined. I is what?
Imaginary.
Is imaginary. It's the square root of -1, right? So what would happen if we did this? I'm trying to get to something here. What if we squared that? What if we took this, rewrote this here, and say, okay, well, if I is the imaginary number and the imaginary number is the square root of -1, and if we square this, so we square this whole thing, and we square this thing, well then I squared is equal to, well, what's the square of a square root? Yeah, exactly. It's the thing on the inside. So if you square this thing, it's the thing on the inside. So I squared is -1. So we're going to talk about that in a second, but I want you to know, well, how do we get that? Well, we got that from here. Got that from here. So when we try a problem like this first problem here, so we multiply this, and we want to write this expression as a complex number in standard form. So start with the problem. What is I times the quantity 3 plus I? We start off doing this the same way we do any other algebra. We're going to distribute this to here and to here. So we get I times 3 is equal to 3I, isn't it? And I times I is equal to what? Positive, right, I squared. You're right, Quince. So if you don't mind, I'm going to keep moving this out, Quincy, but you're right. So I'm going to just keep simplifying this. So we have 3I. And then the I squared is equal to -1. So 3I minus 1, which would be equal to, so finally our answer in standard form would be equal to -1 plus 3I is our final answer. Is that okay? Does that make sense? The reason we have to put it in this form is because, remember, we have to go back. We have to put it in the standard form of a complex number. So it has to be the real part first and the imaginary part second. So here's the real part first, the imaginary part second. Is that all right? So here's the second question. Let's see how to do this one. Second question is, so let's close question A. So question B. We take 4I times 6 minus I. Excuse me. Same thing again. Going to distribute to here and then to here. Multiplication is distributive over addition. So we have 4I times 6 is exactly 24I. And 4I times -I is negative 4I squared, which is the same as 24I minus 4 times -1, right? Good job. Which is the same as, exactly. So this is -4 times -1 is 4. So here's that 4 plus 24I, right? Is that okay? Yeah. Yeah, do you want to do that? So the next question. Everybody okay so far? Okay. So the next question, question C. -10I times 4 plus 7I. Again, same as any other problem. Going to distribute our multiplication over our addition, and -10I times 4 is equal to exactly -40I minus -70I squared. -40I minus 70 times -1. So finally the answer here will be, Exactly. 70. And what do you say, Kamari? Minus 40i. Good job. Minus 40i here. Good enough? Can do this with binomial factors also. Let's try that. Same thing, just a little bit different math. So we try this using FOIL. So for question D, same thing, just a little bit different. So now we're going to just use this with FOIL. 8 plus I. If you go ahead and do this FOIL, please. Yeah. Yeah, 40, yeah. Plus 5i. Good job, 8i. Plus I squared. Plus I squared. Right, and I guess at some point you can start doing that. You can say, okay, you know what, I'm not going to put this I squared. I'm going to put in negative 1. So here we'll get, well, what can we do here? Exactly. 40 minus 1 is 39. So, right, so 39 plus 13i is your final solution here, isn't it? Nicely done. Let's do one more. We do one that looks just a little bit different, if you don't mind. Let's do this one just to make sure we understand how this works and a way to practice this other skill. 3 plus 10i quantity squared. What does this mean? Are we allowed to take this, think about this for a second, are we allowed to distribute this exponent? Are exponents distributive over addition, yes or no? Really important. Exponents are not distributable over addition. That is to say, this is not equal to 3 squared plus 10i squared. Not distributable. So what does this mean? How do we have to rewrite this? Exactly. That's so smart. Thank you. This is crucial. That what we need to remember is that this is 3 plus 10i times 3 plus 10i. And if you try to distribute this, you're going to leave out that middle term, aren't you? So nicely done. Very, very smart. Right. My only point in showing you this problem was just to remind you that, as a way to, just as a teachable moment, just to remind you that even with this, that exponents are still not distributable over addition, and this is addition here. So we have 3 times 3 is 9, yeah, right? 3 times 10 is 30i, is that right? Check on my math here, 30i. 10i times 3 is 30i again, isn't it? And 10i times 10i is 100i squared. What do you want to do with this I squared here? Negative 1, and what's 100 times negative 1? Negative 100. It's just easy for me to negative 100. Is that all right? And then what am I going to do with this and this? What does this turn into here? Negative. Good job. Negative 91. So negative 91 plus what? Plus 60i is the final answer here. Is that all right? Let's do this one last one. I guess we have a little bit of time. So this last one here.
I don't want to confuse nobody, but that 30i, that never turns into 30 negative 1, right?
No. No, that's a good question. These are the same. When you're adding this is 30i, 30i, right? They're not being multiplied. 5 plus 5 is not 5 squared. It's 5 plus 5, right? So that's a good question. I's plus i's is just, right? Good question. No, that's okay. Right? We're not multiplying these. We're adding, right? Right? 5 times 5 is 5 squared, not 5 plus 5. So good question. Good. Here's another one. What would this one look like? If we did 7 plus 5i times 7 minus 5i. Anybody remember what this is called? We're looking at it kind of backwards. Difference of squares. In a second, we're going to see something will actually go away. Let's see how this works. Ready? 7 times 7? 49. 7 times negative 5i, negative 35i. 5i times 7, positive 35i. See how it's going to go away there? Positive 35i. And then lastly, 5i times negative 5i, negative 25i squared, right? What happens with this and this? Negative 35i, positive 35i? Yeah, you cancel. Very good. And what happens here? Negative 1, and this is negative 25, so this becomes positive 25, right? You see, so because this becomes, right? This becomes a negative 1 here, right? Negative times a negative is a positive, so this becomes positive, right? So positive, look what happens here. What happens to the imaginary part? Is there any imaginary part here anymore? No, there's not. 25 plus 49, 74. Is it 74? 74 is our answer. Okay?